factoring by grouping. Factoring by grouping is kind of like the X method, but it's the method we use for most 4 terms. Whenever you have a polynomial with 1, 2, 3, 4 terms, you usually are going to want to try and factor by grouping. Okay? So this works specifically with 4-term polynomials. It does not always work, but it is quick, and it's much better than doing long division, so it's worth always trying. So we are going to take a look at what it looks like to factor by grouping. Now, its name is not very clever because the first step you are going to take is called grouping your pairs. So since this has 4 terms, our first pair is the first 2 terms, and our second group is our last 2 terms. So here's what it looks like to group it. In math, we group things with parentheses. So the first 2 terms, you're going to put parentheses around them. Group them together. Z to the third plus 5z squared are now a group. Put them together. Okay, we're going to put parentheses also around the the last 2 and group them together. So we created 2 separate groups. Group 1, Group 2. Group 1 and Group 2. That is your first step. You want to always make sure that the symbols get put in your groups too. You don't want to leave anything outside of your parentheses. Step number 2 is we are going to take out some common terms. So GCFs and any variables we can take out. We're going to do each group separate. You do not have to take out the same thing for both groups. You're going to do them entirely separate. So right now I want you to ignore the second group. Just pretend it's not there. And we're only looking at z to the third plus 5z to the second. What can we take out of both of those terms? If it helps too, you can always put in your invisible 1. Can we divide 1 and 5 by anything? We can take out a 1. Okay, how many z's can we take out? 2. Okay, you always look at the smallest one. The smallest one in my first group is z squared, so I can take out a 1z squared. Does that make sense? Okay, so whenever we take something out, we write it out front. So we're going to take out 1z squared. And we need to figure out what is going to be left over. If I take away 2 z's from 1z to the third, how many z's does it have left? It's just going to be a 1z. If I take away both z's from the 5, what's going to be left? Just the 5. 1z plus 5 is all that is left. Our goal here is taking out as much as you can. So the most we could take out was a 1, and the most we could take out from our variables was a z squared. Okay? We're going to do the same thing for the second group. What can I take out of, divide -4 and -20 by? -4. And here's why we want to do -4 instead of +4. Okay, because when we take or divide out our 2 things, we want to try to make it look the same. We don't want a minus in between, we want a plus in between so it'll match our first one. So we're going to take out a -4. So write the -4 out in front. And now we're going to divide both of them by -4. And why couldn't I take out any z's here? 20 didn't have one to take, so we couldn't take out any z's. Okay, what am I left with when I divide -4 by -4? Just left with a positive 1z. And look, it's starting to look like my other one. And then if I divide -20 by -4, I get +5. And look at that. Do you see how our two groups now are exactly the same? See that? Okay, if we took out a +4, then these would have looked the same. So after step 2 is done, you should notice that both groups in your parentheses are now exactly the same factor. So those two factors are the same. Step 3 is a little bit of like reordering. We're kind of going to reorder this. So I have these two factors, which are the same factor, inside these parentheses, but I also have these numbers floating on the outside. So here you're going to have to bear with me. To understand this, you have to look at this first clump is one term, and this second clump is a second term. So one term, all of that is one term. All of this is one term. And what do both terms have in common? What do they both have? They both have a z plus 5. And when two terms have something in common, what can you do with it? Throw it out front. Remember, both of these had z squared, so what did we do with it? We threw it out front. Both of these terms have a 1z plus 5, so we're going to throw them out front. 1z plus 5. We threw it out front. So I got rid of this, I got rid of this, and I threw it out front. What didn't I cross out? What's left? There's a -4, and what else? So that's what is left over. Oops. I'm left with a 1z squared and a -4. So I have 1z plus 5 times 1z squared minus 4. Now, we're done with grouping. But it's kind of important at this point to make sure and see and check, are we actually done with factoring? Yeah? Here to here. So, they both had a 1z plus 5 in common, so we threw it out front. And what was left was 1z squared minus 4, so that made our second factor. It's kind of, you have to think of it like we're reordering it. It's strange though. The two binomials in common get factored out and put out front, kind of like how we took a z squared and put it out front. And then the two highlighted green terms were left over after factoring out 1z plus 5, so they create the second part. Now, I wish we were done. Sometimes you are done at this point, but I'm interested in this right here. This polynomial, what is its largest exponent? It's a squared, it's a 2, right? And what do we call those? Like for example, if the exponent was 3, it'd be called a cubic. Anytime there's a squared, it's called a quadratic. And what method can you use to factor quadratics? The x method. But what's weird about this one? There's nothing in between. Now, just because we can't see the middle term, does that mean it's not there? What is the middle term? It's 0. So we're going to do the x method to finish off this problem. My a value is the 1 z in front of the z squared. The c value is the -4, and I know that's c because it's my normal number. But the b value seems like it's not there, which, you're right, it's not there because the b value is nothing. It's 0. So we're going to say b is 0. Okay? And now our x method will work just like it normally does. So a times c on top is -4. My b value goes on the bottom, so on the bottom I'm going to put 0. Does that make sense? Okay. What two numbers multiply to -4 and add up to 0? 2 and -2. And what am I going to divide both of them by? 1, so it's going to stay the same. 2 and -2. So this polynomial is actually going to split up into what two factors? X plus 2 and x minus 2. And we still have the 1z, or just z plus 5 that we had. This is now entirely factored. So after step 3, you're done factoring by grouping. So right here is kind of where factoring by grouping ends. This step 4 is just to let you know. At step 4, you need to check and see, is there any more factoring you can do? If you can, you should factor more. If you can't factor anymore, then you're done. You won't always have to do that next x method. Just depends on the problem. Something you should check, though. I think the best thing we can do is do one more, yeah? I'm going to scroll down. Is that all right? Is that good? Okay, example 2, I want the first thing for you to do is to group it. So group your first two terms, group together your second two terms. Group 1, group 2. Group 1 is my first two terms. Group 2 is my last two terms. Which, again, this is why it's called factor by grouping, because the first thing you do is make two groups. Now that I have my two groups, what am I going to try to do? Take out as much as I can. So in the first group I made, what can I divide 12 and 9 by? Biggest number you can think of. 3. 3 is the biggest number you can divide 12 and 9 by. You can always use your factor sheet to help you find that. How many a's can I take out? 2. Since I have an a to the squared and an a to the third, I'm allowed to take at most 2 a's, a squared. Okay, we got to figure out what's going to be left over. 12 taking away 3, 12 divided by 3 is 4. I had a to the third. I'm taking out an a to the second. So I'm left with just then a. Bring down the minus. 9 divided by 3 is 3. I had an a to the squared and a second, and I took away a to the second, so now I have no more a's left over. And look already. You see how they're starting to match? Okay, so if we look at our second group of two terms, 4a minus 3, what's the only thing you can divide them both by? 1. So let's put the plus 1, positive 1 out front. A divided by 1 is still just, bring down your minus, 3 divided by 1 is still 3. And this is good because, again, we now have these two factors that match. And this is the weird part about factoring by grouping, is this right here is all one term, and this is all one term. Both of those terms have a 4a minus 3 in common, so we're going to factor it out and put it out front. So out front we have 4a minus 3 what was left is 3a squared plus 1. 3a squared plus 1. A squared plus 1. What should we check before we decide if we're done? We need to see, can we use the x method on 3a squared plus 1 because that's a quadratic. Okay, and its b value is 0. So if we just quick off to the side, check our x method, a times c will give us, our b value is 0. Now, are there any two numbers that multiply to 3 and add up to 0? What's the only way to make 3? 3 and 1, did those add up to 0? Can you factor this? No, so that means we are done. Isn't this method nice? It's quick. That's why whenever you see a 4-term polynomial, before you do long division, I would always try to do this first. Whenever I see a 4-term polynomial, I don't want to do long division. I try to do grouping first. Does not always work, just like factoring doesn't always work. But when it works, we're happy. Example 3, make your two groups. Group. First group, second group. What's the most we can take away from our first two groups, first two terms? What can you divide 8 and 64 by? 8. Yep, we can divide them both by 8. How many r's can we take out? 4. R to the 4th. What's left over? 8 divided by 8 is 1. We had r to the 5th. We took out an r to the 4th, meaning I have just an r left over. Yeah. 64 divided by 8 leaves me with 8. I had r to the 4th. I took out all 4 r's, so it's just going to be that 8. I should have put my little invisible 1 in here, and then r to the 3rd. What can I divide a 1 and an 8 by? Just a 1. How many r's can I take out of the second group? Yeah, so I can take out a positive 1r to the 2nd. Okay. I'm going to take out my 2 r's and I'm left with just r. If I take the only 2 r's that 8 has, I have just minus 8 left. And look at that, we have our matching factors. We have our 1r minus 8s. Since those are exactly the same, we can factor it out and put it out front. And what's left over is 8r to the 4th and a 1r to the 2nd. This one's got some tricks in it. Now we're done grouping, but we're going to have to take a look at this. Now, any ideas what we can do with this? It's not a quadratic, right? Because it's to the 4th power. Remember, that's called a quartic. It's not a quadratic. However, do those two terms still have more we can take out? What do they both have? How many r's could we take out still? 2. And whenever we take something out, where do we put it? way out front. So I'm going to kind of go up to this top half over here. So I don't run up. So I'm going to take out an r squared. Okay, I can take out 2 r's from both of these. So I'm going to take them out and I just write it way out front. Okay, I'm going to be left with 8r, I took 2 away, so 8r squared, plus 1. Can I be done? I mean, in theory, yes, we could call it good, but should we call it good? What is this? It's a quadratic, right? So I need to at least check to see if I can do the x method. Because we don't know. This might be able to be factored more. It might not. We don't know until we try. So we can do a little x off to the side. A times c, because this is my a and c, is 8. My b value is 0. Can anyone think of 2 numbers that multiply to 8 and add up to 0? There's only 2 ways to make 8. 1 and 8, that adds up to 9. And 2 and 4, that adds up to 6. So, can you factor that? No. So that means we are done. That is as factored as it can get. Remember, we are just tearing apart polynomials as much as we can. We don't want to stop until we're sure. That is, pull apart as much as we can. This is when grouping ends. If you can get this far, then that means you know how to group. We are done.
E for me, field trip.